Lesson 10.10, function analysis with E, level 2. And it is level 2 because now they want us to find concavity intervals. And so that means we have to take the second derivative or get to the second derivative. So here's my original function. First derivative looks like a product rule because this is all one function times e to the negative x. So I'm going to keep the first part, negative 5x squared plus 5x times derivative of e to the negative x would become e to the negative x, but then the derivative of negative x is negative 1. So I might float that negative in front. Plus, then it would be derivative of this first part would be negative 10x plus 5 times e to the negative x. Okay, then I would go ahead and fix this a little bit, distribute the negative, so that would become positive 5x squared minus 5x times e to the negative x. And then I'm going to factor out my e to the negative x. And I'm going to have 5x squared minus 5x minus 10x plus 5. I'm setting this equal to 0 and trying to factor it. Oh, actually, I'm not. No, what am I doing? I want to just, forgot for a second that I am actually doing second derivative. But I'm going to still simplify this. That would be 5x squared minus 15x plus 5. Then I get to go, again. First derivative. First derivative is this. Second derivative, another product rule. So I'm going to take the derivative of, well, I'll stick to my rule here. I'll keep the first, take the derivative of the second, so that would be times a 10x minus 15 plus, take the derivative of this would be a negative e to the negative x times, keep this, 5x squared minus 15x plus 5. Okay, I'm going to distribute this negative to all of this. So that would get a negative 5x squared plus 15x minus 5. Okay, factor out my e to the negative x again. All right, can I put this all together? I'm just adding this. So I've got my negative 5x squared. 15x plus 10x would be 25x. Negative 15 minus 5 more would be negative 20. So then my goal is to factor this. I would take out a negative 5. And then I would have x squared. I never want this to be negative. X squared minus 5x plus 4. That we don't worry about. That we don't worry about for an answer. This would get x minus 4 times x minus 1. Whew. All of that just to figure out concavity is going to change maybe at 1 and 4. So if I plug in 5, 5 minus 4 is positive, 5 minus 1 is positive, this is always positive, but then times this negative 5 makes it negative. At 4 it's going to change, and at 1 it's going to change. Where is it concave up? Would be right here between 1 and 4. Okay, and then one more of these. They're all going to be product rule, no quotient, because that would get disgusting to take the second derivative of. But we're going to just see where it has an inflection point. So remember, it has to change concavity. I've got product rule. I would keep my negative 3x times e to the negative 4x minus 1 times the derivative of negative 4 plus derivative of negative 3x is negative 3 times e to the negative 4x minus 1. So this would get 12x times e to the negative 4x minus 1 take out my e. That would leave me with 12x minus 3. And then I have to do second derivative. Keep e to the negative 4x minus 1 times the derivative of just 12 plus derivative of this would be negative 4 e to the negative 4x minus 1 times, keep the 12x minus 3. We'll distribute the negative 4 to the 12x. That would be negative 48x plus 12 times e to the negative 4x minus 1. Factor out your e. And then that would give me negative 48x. 12 plus 12 would be 24. Factor out a negative, well, it doesn't matter, but I'll do a negative. 24 would be a 2x minus 1. Set equal to 0. We don't worry about that. We don't worry about that. And then this would get 1/2. So my sign chart only has one critical value. If I were to plug in 1, that would get a positive times a negative. So it'd be negative, and then it's going to switch signs. So I do have an inflection point right here at x equals 1/2. Ooh, that's a doozy, but that is our last lesson.